This conference will now be recorded.
So very good evening, students. Today we are going to discuss some more questions on NEET UG Paper 2023, which is just over in the last week. Okay, so we have picked up few questions. We have already discussed few questions in the previous two sessions. Today also we'll continue that. Okay, so let us start today's discussion. So the first question says, light travels a distance x in time t1 in air, 10x in t2 in another denser medium. What is the critical angle of the medium? That means, if I have a rarer medium here, suppose air, and this is water. This is the interface, and light will be traveling here with certain velocity that is given here. Okay, and velocity with which it travels in the other medium, it is actually denser to rarer. Okay, so I'll put it here. Critical angle means total internal reflection comes here. So denser to rarer medium, light is traveling from. So light is traveling from denser to rarer medium. So here it will be like this. Anyway, what is given is that the speed of light in air is given. That we know, right? That can be denoted by c, and it is here according to the given problem. It is x by t1. And the speed of light in the medium water, let us say denser medium water, that is written as v is equal to 10x by t2, right? Now see, if we want to write the relation between critical angle, or here we have to find out critical angle. So we know critical angle, at the critical angle of refraction will be 90 degree. So from Snell's law we can write I, that let us say this is refractive index of the water is something like n1. Okay, sine theta c is equal to n2 sine 90 degree. So this is sine theta c. This is the critical angle, and this is the refractive index of the water. So sine theta c is equal to 1 over n1, and this is in air, it is 1. Okay, sine theta c is this. So what we need to find out is the refractive index. So how do we define refractive index? So in this case, n1 will be v by c, that is v is 10x by t2, and by c, oh no, I'm sorry, c by v. Refractive index is greater than 1, so it is c by v, c by v, x by t1 c, and v is 10x, so t2 by 10x. So this can be cancelled from both places, so it will be actually t2 by 10 T1. Okay, so refractive index should have got, then theta c will be sine inverse 1 over n1, which is, so 1 over n1 means T2 divided by 10 T1, or we can write sine inverse 10 T1 by T2. Look here, option this one. So option C will be the correct answer for this question. Okay. So this you have to remember this relation for critical angle. Okay. Now we'll go to the next problem. This is also a very simple problem. It is said that a 12-volt 60-watt lamp. So 12-volt 60-watt lamp. What do you mean by 12-volt 60-watt? That means this is the rating of the power. Sorry, rating of the lamp. And that lamp is connected to the secondary step down transformer. Secondary transformer, whose primary is connected to AC mains of 220 volt. I am just trying to draw the scenario. So this is a problem from transformer. So this is the primary coil of the transformer whose ends are connected to an mains AC mains of 220 volt. AC mains of 220 volt. Okay. Now in the secondary coil, that bulb is connected. That bulb is connected to the secondary. Kind of this. Okay. So this is secondary, this is primary, and the bulb has got power rating 20 volt 60 watt. Okay. Assuming the transformer to be ideal, what is the current in the primary winding? We have to find out what is the current in the primary winding. Let us say that is IP. If the transformer is an ideal transformer. Ideal transformer means it has 100% efficiency. That means, for an ideal transformer, what we can write? Ideal transformer. We can write VP IP is equal to VSIS. I'll tell you what it is. See, actually transformer works on mutual induction, on the principle of mutual induction. So if the transformer is ideal, the same power will be induced in the secondary coil. Same power will be induced. Okay, that's why we can write IP must be VSIS by VP. What is VS? VS is the voltage. Here the specification of the bulb is given 12 volt 60 watt. So VS is 12 volt. What is IS? IS is the current in the secondary. How do you find out that? See, what is this given? Power is given to 60 by 12. Okay, this will be 5 ampere. Okay, IS will be 5 ampere. So we have got And VP is what? Here VP is see 220 volt. So we have got VS as 12, IS as 5, and we have got VP as 220. Okay, 220. Then what will be the IP current? So you look this I can write like this. This is 6. Okay, here we can write this as, so 3 by 11. So 3 by 11, so 11, and this is 3. We can write, see, we can just go with point, so will be, sorry, this is actually 12, sorry, 22, 20 means 8 here, 8, so it will be 7 here, again 3 will come, so here it will be again 2. So approximately 0.27, 0.27 ampere. So this is D will be the answer here. Okay. So ideal transformer. So you have to write down the transformer equation. See, this is the fundamental point here. You need to remember that in case of ideal transformer, the same power will be induced to the secondary coil. Okay, we'll go to the next problem. This is a nice problem. See, here in this problem, it is said that a football player is moving southward, suddenly turns eastward with the same speed to avoid an opponent. The force that acts on the player while turning. So this is a nice problem. Let us see. Suppose this is in north, this is south, this is east, and this is west. So initially the football player was moving towards southwards. Okay, this way. Towards southwards, this way. Then he turns suddenly in the eastward direction. That means in this direction. Okay, in this direction. The question is, the force act on the player while turning. So how do we find out force acting on the player? In this case, look, force means what? Definition of force is dp/dt, or change in linear momentum. Change in linear momentum. Linear momentum is force according to the definition. So the force act on the football player will be found out if we can find out the change in the linear momentum. See, anyway, mass is constant, so we can write the force will be directly proportional to change in the velocity, or it means change in the velocity. I'm writing the magnitude, so it will be, suppose it was having velocity speed v1, obviously with vector sign, sorry, v1, and at the last it has become v2, so v2 minus v1, this will be actually change in the linear momentum. Let us say, see here you have to find out the direction, not the magnitude. Okay, so let us say the velocity was earlier v alone. Okay, I'll just show you here. Velocity was in this direction, and anyway I have to find out v2 minus v1 vector. So what is v2? See, according to vectors rule, we need to see if we want to do this thing. We'll write. We don't know what is how subtraction is done. We don't know subtraction of vectors, but we know addition of vectors. We'll do this thing. Okay, let us say the velocity is same as it is told already. Velocity is same. Okay, so for the time being, let us write this v2 and v1. So in this case, look, this is v2 because it is each direction, and this way it is v1 minus v1. So resultant of these two vectors obviously will be in this direction. Okay, equal vector, so it will be making 45-degree with this x-axis. Okay, so it will be actually along the northeast direction. So this is the change in the linear momentum. Okay, so guys, you have understood this along the northeast direction. Now we'll go to the next problem. So this is a problem from electricity, and here we have to apply Kirchhoff's law to solve this problem. See, in this problem, it is said magnitude and direction of the current in the following circuit is. So the magnitude and the direction of the current you have to find out. See, this has got a single loop itself. We'll just do this job. Let's say the current, since all of them are in series, so the current will be same for the same through 2 ohm here, 1 ohm and 7 ohm. Okay, so I'm just taking I is the current in the circuit, and this is how, let us say the current is flowing in this way, A to B, B to C, C to D, and D to A. So after the solution of Kirchhoff's, like after writing the equations, current voltage equation, or writing the KVL, once we get the value of I, if that is becoming negative, then we will say the current is flowing in the opposite direction to the direction which we have chosen. We have chosen now the direction A to B, current is flowing. But suppose the value of current is something like minus 5 ampere, that means current has to be flowing from B to A, not from A to B. That is what I wanted to mean. That means in Kirchhoff's law, whenever you are doing the calculation of current, if the value of the current is coming as negative, then you must be understanding that the direction we have chosen for the current is just opposite. That is what we need to take care. Now here, see, if I apply Kirchhoff's voltage law, KVL, see, I'll write 2 into I, okay, 2 ohm into I, so 2I plus, see, I just take the register first, I plus 7I. Now I'll take the battery EMF. See, in this case, we are going from A to B this side. So current is flowing from positive to negative for this 10 volt cell of 10 volt. So it has got positive voltage, and see here the current is just emanating from negative terminal of the battery. That means we have to take this EMF to be -5. So resultant of this will be anyway 5 volt, and here we have got 10 I. So 10 I is equal to 5 volt. So I is equal to 5 by 10. So it will be 0.5 ampere current, and it will be, see, since it is positive, it is coming positive, we have taken that the current is flowing A to B through E. Okay, A to B. So 0.5 ampere from A to B through E. So the first option will be the correct answer for this question. Okay, we'll move on to the next problem. So this problem is you don't have to calculate any numerical values here. This is problem from the circular motion. See, angular acceleration of a body moving along circumference of a circle. See, if a body is moving along the circumference of this circular path, see, at any point the linear speed will be along the tangent, that is linear speed. But what about angular speed and angular acceleration? So linear acceleration will act along the center, but what about the angular acceleration, angular velocities, etc.? See, if I say this is so, the angular acceleration always acts along the direction, or along the axis of rotation, actually along the axis of rotation. Even see, omega also axis of rotation. Okay, so angular acceleration will be along the axis of rotation, and here you can apply thumb rule as well to find out direction. Sometime if you have a current loop like this, so in that case, angular acceleration, you can just so it is this one, that along the axis of rotation, the angular acceleration will be along the axis of rotation. So we'll go to the next problem. So this problem is again an interesting problem. Say a bullet is fired from a gun at the speed of 280 meters per second in the direction 30 degree above the horizontal. The maximum height attained by the bullet is. So I'll just explain the question once again. This is actually projectile motion. Suppose a gun is aimed at this direction, which is actually 30 degree above the ground, and a bullet is fired with velocity, suppose some u initial velocity, that is 280 meters per second. 280 meters per second Okay, now you have to find out the maximum height attained. See, how do you find out a maximum height attained? We know it is motion under gravity. If you cos theta, so it will have u cos theta along this direction, and in this direction it will be u sin theta. So the vertical motion is actually governed by the velocity, initial velocity uy, that is u sine of theta. Okay, that is the velocity. Now if you want to find out maximum height can be obtained. See, I can find out that by this formula, b square minus u square, b square minus u square minus 2 gh. H is the maximum height attained. So here the final velocity at maximum height will be 0. So we get u square is equal to 2 gh, or h is equal to u square by 2g. What is u square? See here, uy, actually uy I should write. So uy is 280 cos of theta, that means cos of 30. I'm sorry, this is not cos, this is sine theta. I should take sine theta, sine 30 degree. So uy we are getting as 280 by 2, because sine theta is equal to half, so it will be eventually 140 meter per second. So this we have got. Now formula for maximum height calculation is u square by uy square by 2g. Let us find out that h is equal to u square by 2g. uy is 140, 2g. G has to be taken as 9.8 meter per second square. So this is the thing you have to calculate here. See, if I write 140 here divided by 2g, this is not square, 2 into 9.8. Okay, now let us multiply this 10 here up and down, so it will be this 98. So I can write this as 10, this to 7, 14, so 14, 7, 14 to okay. So if we further go, this will be 2 0, and this will be again 1 0. So this 10 10 10. So this will be actually 1000 meter, 1000 meter. Okay, the height will be 1000 meter. See, the second option will be correct. So this was also a very simple problem. Okay, so now we'll pick up few more problems which I have not written. I'll just give you here and try to solve them. Okay, so one simple conceptual problem, problem number 7, say the net magnetic flux, the net magnetic flux through any closed surface, through any closed surface through any closed surface is positive, then infinity, C is negative, and D is 0. So look, the question says this thing. Mathematical form, if you see, then you may be able to remember. This is what? This is equal to 0 because this is Gauss's law of magnetostatics. Gauss's law of magnetostatics. Magnetostatics. And what does this signify? This signifies no monopole exists. No monopole exists. So no monopole exists. Monopole is magnetic monopole. Magnetic monopole. So magnetic bars also, that's why there will be positive and negative. So no magnetic monopole exists here. Okay. So that is what we have to find out. So what does this mean? No magnetic monopole exists. No magnetic monopole. Okay. So it will be the D. Now I will take another problem. See, this is a problem from electrostatics. The equivalent the equivalent the equivalent capacitance of the system as shown in the figure below, shown in the figure below. Figure below. So what is the figure or circuit? These are all capacitors. You should remember this. Okay, so this is 3 microfarad. This is 3 microfarad. 8. This also 3 microfarad. This is terminal B and this is terminal A. Now, see, we have to find out equivalent capacitance. Options are given 3 microfarad. Option B is 6 microfarad. Option C was 9 microfarad. and option B is 2 microfarad. See, we know this combination, you know, this the same, their terminals are, these two are in parallel combination because their terminals are connected to a fixed one point. So, you know, when we say this 3 parallel 3, then it is just addition, algebraic addition of two vectors c, sorry, 3 plus 3. So 3 plus 3, this will be 6. And see, now equivalent circuit is, see, I have got this now. So this is 3 microfarad and this is 6 microfarad. Six microfarad. Now these two are in series. Now these two are in series. 6 microfarad and 3. So you can write one multiplication by, see, this is equivalent capacitance, will be directly multiplication 3 into 6 divided by, see, this. So this is 18, this is 6. 18 by 9. So it is actually 2 microfarad. So here D will be the correct option here. Nothing to say too much about the combination of the capacitor. Okay, we'll move on to the another problem. Okay, so I think we'll stop it here for today. We'll take up some more questions, like some more in the sense we are just on the halfway. We have to solve another 25 questions in the subsequent sessions from this NEET UG paper. By the way, the question was very easy for this time, the physics part. Anyway, so we'll meet again tomorrow. Bye for today. Thank you for your patience.